friends, we are already done with the image formation by convex lens. So today we are doing the image formation by concave lens. For now, again, as our convex lens behaves quite like concave mirror, because you must have noticed that all the cases are similar. Though the difference between a mirror and lens would always be there, that mirror offers us reflection and lens is offering us refraction. But keeping this aside, we saw that all the 6 cases that we had in case of concave mirror, similar cases we obtained in case of convex lens. And all the observations were similar, like position of object, position of image, size of image, and nature of image, all obtained were alike. Those were what we obtained in case of concave mirror. So similarly, now when we are talking about concave lens, so here it's clear that concave lens would behave like convex mirror. So now just remember, how does the convex mirror behave? So you must have remembered that convex mirror always gives us virtual and erect images. Moreover, the images formed are diminished. Well, in case of mirrors, virtual and erect images are formed to the right side of the mirror, that we used to say at the back of the mirror. But that situation is opposite in case of lenses. In lenses, if we talk about virtual and erect images, then they should form to the left side of the lens itself. So now just quickly remember the first case of convex mirror. Well, in case of convex mirror, we only had 2 cases. So similarly, in case of concave lens also, we have only 2 cases. So the first case is when the light rays are coming from infinity. Since concave lens is a diverging lens and it offers refraction, so when the light ray would fall, they would refract, and they're definitely going to diverge. But by the rules that we had discussed of rays, that whenever a ray is coming parallel to the principal axis, be it in case of a mirror or lens, like whether it undergoes reflection or refraction, it will either actually converge at focus, or it would appear to be diverging from focus. So here again what we need is that these 2 rays, they are diverging one, and for image formation we want intersection of 2 images. As I earlier mentioned, that diverging rays are never going to intersect, so we can't expect these rays to give us some common point of intersection, because if they will move forward, they will just keep on diverging, and the distance, the divergence would increase and further and further. So what is the other way around? The other way is to extend the rays backward so that we can actually get our point. So since in case of concave lens, the rays which are coming parallel to the principal axis, after refraction they appear to diverge from focus. So this ray would also appear to diverge at focus, though actually it is going like this, in this direction. And similarly, this ray would also appear to be appearing from focus. So here, just by extending these 2 rays backwards, we are getting a point of intersection, and that point of intersection lies none other than at principal focus. So our image would form at principal focus. The object is at infinity, so it's at very far away distance, almost at infinity, no approachable distance of in the vicinity. It's not in the vicinity of the lens, it is at infinity. So object is infinity, and since on extending these rays backward, we get this as the point of intersection, which is focus. So since the point of intersection of images always gives us the head of the image, and we know that the base, the bottom of image always lies on the principal axis, as this is our principal axis. Since the point of intersection itself lies on the principal axis, that means this only is our image, which is very, very small. So we are getting a point size and highly diminished image. And about nature of image, it is going to be virtual and erect. As we know, in case of lens, if image forms to the left side of the lens itself, that is from where the object is placed, then it is always virtual. And if it is virtual, it is going to be erect. So this case is similar to the first case of convex mirror. It's just the same. Now our second case. In case of second case, we would only mention that our object is placed anywhere in front of concave lens. So, as convex mirror only had two cases, similarly concave lens also has only two cases. First case when object is at infinity, and the second case when object is in front of the lens but anywhere, like it is in the approachable distance. It is not at infinity. Any object which is placed not at infinity, that means it is placed at some approachable distance in front of concave lens. So these are the only two general cases that we are going to have in case of concave lens. So here again, the one thing I would like to mention here is that in case of mirrors, when we talk about concave mirror, convex mirrors, we actually talk of four types of rays, out of which at least two are required to get us the position of image. You must remember that we had either the ray coming parallel to principal axis, or the ray which is directed towards focus, or the ray which is directed towards center of curvature, or the ray which is directed towards pole. So there were four types of rays, and we actually choose which two would actually be hitting and which two would actually we should use when we make our ray diagrams. So we choose out of those four, and then the intersection of two rays give us the position of image. But in case of lenses, there is no such a big deal. All we have to remember is that there is just one ray which is coming parallel to principal axis, which will definitely, if it is convex, it will actually converge at focus, or in case of concave, it would just appear to be diverging from focus. And the other ray is always directed towards optical center. And the ray which is directed towards optical center, it just emerges out without getting deviated. So this is the easier thing, that we always have to use these two rays, and just by changing the position of placing the object, we can get our desired result. So here one ray is coming parallel to principal axis, which of course undergoes refraction. By retracing it back, we find that it appears to be emerging from principal focus, and the other one is directed towards optical center, and it will just go straight. So now the intersection of these two rays is here. This is the point, and since this point lies above the principal axis, and we know that the bottom of image always lies on principal axis, so it is going to be an erect image. So, and also the image is lying to the left side of the lens, so it is virtual also. So in case of position of object, we say that the object is placed anywhere in front of the lens. In case of concave lens, the position of object doesn't matter. Like, we only have two cases, either it is at infinity or it is at anywhere in front of concave lens. So we don't talk of these special cases like whether it's at center of curvature or focus or in between. There are no such special cases. So similarly, here the image that will form, that is also in front of lens. We are not considering the special cases that where it is. We are only concerned with this case that it is going to be in front of lens. Usually in case of convex lens, most of the images, they are formed to the right side of the lens. But it is only the concave lens where the images are always formed in front of the lens. So we are not going to describe any specific position here because it really doesn't matter. As you can see here, that the point of intersection always gives us the head of image, and this is the height of image, which is smaller than that of the object. So our image is diminished, and this is also the similar case, that as convex mirror always gives us diminished images, Similarly, concave lens also always gives us diminished images. So in the first case, we had point sized image, and in the second case, we are getting diminished image, and there are only just two cases. The point of intersection lies above the principal axis, so that means our image is going to be erect. And whenever the image is erect, it is virtual, because it's only the virtual image which comes out to be erect. Real images always come out to be inverted. So if it is erect, that means it is virtual. And also, if image lies to the left side of the lens, it is always virtual. That means it cannot be obtained on screen. So here again, this whole case is similar to the second case of convex mirror. So now we conclude that concave mirror and convex lens, they just move, they have the similar cases, you can say, though both are different. In case of mirror, we observe reflection, and in case of lens, we observe refraction. So ideally, in case of mirror, image should form in front of the mirror itself. And if it happens, then images are usually real and inverted. And if images are formed to the right side, that means at the back of the mirror, then it comes out to be virtual and erect. And this case is opposite in case of lens, because lens offers us refraction. So ideally, image should form to the right side of the lens. And if it happens, then image is real and inverted. But if image forms to the left side of the lens, that means the side where object is already there, then image comes out to be virtual and erect. And all the cases of concave mirror, they are just similar cases we had in case of convex lens, and the cases of convex mirror, they were just similar to those in case of concave lens. So by this we conclude our image formation by convex and concave lens. Thank you.